Okay, today we're going to be doing the next section of 5.3. We're going to be solving trigonometric equations using different factoring techniques. Remember I told you we're going to have to factor with this stuff. Looking at GCF, quadratics, factor by grouping, things like that. So let's just review a quick question on factoring. What would I do for factoring this? I have to set it equal to 0. So I have to add 8, yes. So I have x squared minus 9x plus 8 equals 0. And then we're going to factor it by guess and check. It's got to be x and x. What do my signs have to be? They both have to be subtraction, right? This plus 8 tells me they're going to be the same sign. And then this minus sign right here tells me they're both going to be minus. And then what two numbers multiply together? 8. But then eventually they're going to have to equal 9, negative 9 in the middle. Negative 1, negative 8. Okay. So how would I solve this from here? Set each factor equal to 0. So I have x minus 1 equals 0. X minus 8 equals 0. So x equals 1. X equals 8. So we just went through the factoring steps. First thing is it has to say equals 0 or you can't do it by factoring. Once it says equals 0, do factoring. Once we have it factored, set each factor equal to 0 and then solve each factor. Those are the steps for factoring. My second part of this equation, when we're solving this equation, what are we finding in regards to a graph? What is the 1 and the 8 for this graph? X-intercepts. So this would be a parabola for this particular equation that would hit at 1 and 8. And looking at my x squared, it's positive, so this parabola would be like that-ish. It would hit here at 8. Okay, so we're finding x-intercepts. So any of these that you wanted to check, you could use Desmos to check it, and you'd be looking at x-intercepts. First example, 3 cosine squared x minus sine x cosine squared x equals 0. What is our first step of factoring always? Is there a GCF? What between the, or separated by the minus signs, what is common? Okay, so I'm going to factor out the cosine squared x, and I'm going to put it out front. Gosh, I totally forgot to remind you about something. Somebody's trying to get in. Oh, hi. Okay, so we factor that out. So one thing I forgot to remind you about because it was already done, what is our first step of factoring? Has to be equal to 0, and I saw it was already done, and I just forgot to remind you. If it's not equal to 0, we need to make it equal to 0. Okay? Mike, how's your day?
Good.
Oh, good. Do you know what I do next? What do we do next up here when we made it? Oh, after factoring it.
Yes.
We already factored it. So we've already accomplished this step. So I'm going to go to this step now. Yeah, we're going to make each factor equal to 0. Excuse me. Marco, what do I do next? Solve what? The two equations, right. We're going to solve each equation. So we're going to look at cosine squared x equals 0. Kate, I can't have cosine squared x. What do I need to do? Square root? That kind of radical? But if I square root, what also should I do? Everybody. Good, plus minus. So now we have cosine x equals plus minus, what is the square root of 0? Okay, do I even need the plus minus? Nah. There's no positive or negative 0. Were you joking or were you being serious? Okay. I thought so because you were smiling, but I wasn't sure. All right, how about solving this one? I mean, I didn't finish solving this one. I'll go back and solve it in a second. But what should I do for this one first? Add sin x, yeah. It's easier to add the sin x than it would be to subtract the 3 and then divide by -1. Right. All right, so now we have two completely separate graphs to find the answer for x. We're going to find those angles. You guys take 30 seconds or so, see what you can figure out. Make sure when you do find the answers, they're put in numerical order. This is the same stuff we've been doing for the past week-ish, maybe even a week and a half. Other than the factoring stuff is new today. Anybody else stumped on part of it? All right, you guys are doing an excellent job. Morgan, did you get the cosine x equals 0? Did you get that one? Did you get the second one? So, Morgan, when we talk about cosine, we're talking about which variable? The x value. So where on this graph can x be equal to 0? Right, either up here or down here. So what angles are those? And what angle is it if I go all the way here to here? Okay, so what is it if I just go halfway? Pi over 2. And then if you're counting by your pi over 2's, what's the third one called? 3 pi over 2. All right, now you really shouldn't put these in numerical order until you found this other answer yet, but I know something that a lot of you don't know. Does anybody know why I went ahead and started writing the answers and closing my fancy bracket? Did anybody figure this out? Yeah. What is the highest value that either cosine or sine could have? Nope. The value, not the angle, but the highest value is a number. Remember when we graphed them? What was the highest up any of these graphs or lowest any of these graphs would go unless we had stretches on it. Thank you. What's the highest that they would go? 1. So the highest that sin x can be is 1 unless there was a stretch on it. And if there was like a stretch on it, then I would divide out the 3's. So this does not have a stretch on it. There is no place that sin x could ever equal 3. So we just can... Bye. Okay. Next one. We're looking here, we've got sine squared x plus 3 sin x plus 2 equals 0. Do I have to set it equal to 0? That part's done. The next part is factoring, and this is how many terms? 3 terms. This is a trinomial. This would be like if I did a u substitution for... If I said wherever I see a sin x, I'm just going to change it into u. That would be like u squared plus 3u plus 2 equals 0. Would you know how to factor this one? Well, trinomials, we make them into 2 parentheses. I look at my signs. They're both going to be plus. What's going to give me 2? 2 and 1. And the u squared would be u and u. But it's not u. What is it really? So I'm just going to put that back in where the u's are. Sine x plus 1, sine x plus 2 equals 0. Jalen, what should I do now? Set each factor equal to 0. Katie, what should I do now? Okay, so we're solving each of these for the sine x. We're subtracting 1, subtracting 2. And once you have sine x by itself, now you can say, where is this sine equal to -1? Where is the sine equal to -2? Take a moment, figure it out. Probably you have it already. Just want to make sure you were not like zoned out. This stuff's really exciting, right? That's what I thought. Peter, you have them? Corey, you get it? You think so? You want to try?
So for -1, we do 3 pi over 2.
Yep, 3 pi over 2.
For -2, would it just cancel out the sine?
Well, it's not going to cancel out, but it isn't a real thing, so we'll just throw it out. Okay, so there's only one answer for this one. Now, I did tell you you can use graphing to check it, you know, to build up your confidence like you're doing it right. Excuse me. You just go to Desmos and type in, sine squared x, x, and then we're going to, oh no, what happened? Okay. Then we're going to plus 3 sine x and plus 2. Then we should change our step value to account by pi over 2 so that we can actually see that it is in radians, and we're going from 0 to 2 pi. So we're only looking at from 0 to 2 pi. We're just looking that far. And from 0 to 2 pi, there's only one x-intercept, and it's at 3 pi over 2. So a good way to check your answers. Okay, next one. 2 cosine to the 4th x equals cosine squared x. Subtract cosine squared x? Why? Because it has to equal 0 before we do anything. Before we do any factoring, I should say. Okay. So I subtracted that. You start thinking about your rules for factoring. Take out cosine squared. So GCF, always first, if there is one. Put that in front. Matthew, what should I do next? Who just answered that? Matthew, what should I do next? Set each factor equal to 0. I appreciate your enthusiasm. Oh, no. I just said Matthew, and then you answered it, so. That's all. That was the only thing. everybody to talk in here, right? Right, Amanda? What should I do now? Solve. Okay, so this one I'm going to square root, and if I square root, I'm going to plus minus, but that doesn't really matter because it's 0. This one over here, we're going to add 1, divide by 2, and do I have to do something else? Dylan? Square root, but what if I square root? What also do I have to do? Plus or minus? So if cosine x equals, so this is the same thing as plus or minus 1 over square root 2, which I really do not have to go all the way and rationalize this, but if you do rationalize it, it's going to be square root of 2 over 2. And I'm just saying that because what triangle has the square root of 2 in it? Like these are going to be pi over 4s. That's the only triangle that has the square root of 2 in it. And then for this one, the first part, where is cosine 0? Already did it today. Where's cosine 0? Pi over 2, 3 pi over 2. The only somewhat challenging part is we just need to put these in order. So we're going to have x equals, what's the first one? Pi over 4. Then what comes next? Good. Then we've got 3 pi over 4. Then we've got 5 pi over 4. 3 pi over 2. 7 pi over 4. How do I know that I did it right? Yeah. Also, Desmos will tell me if I put it in the right order, too. That's not where you want to get your answers because you're not going to get Desmos for a quiz on this, but this is going to help you make sure that you're doing it right to start. So I've got 2 cosine to the 4th x minus cosine squared x. I feel like it doesn't let me put the fourths in. I'm going to try it, but I'm pretty sure it doesn't unless they've changed it from the past. See, it's already saying something's wrong. It only allows cosine squared and cosine inverse. So what you have to do instead when you do fourths is you just have to do like cosine squared. Oops. And then multiply that by another cosine squared x. That way it's making cosine of the fourth. And then we subtract. Oh, I forgot my 2. 2. Now what is it not like? Oh, I know that. Okay. And then we subtract cosine squared x. Oops. X. There we go. What a fun looking shape. Look at all these x-intercepts. We've got pi over 4, pi over 2, 3 pi over 4, 5 pi over 4, 3 pi over 2, 7 pi over 4. Exact same order we wrote it down on our paper. Yay, check. All right, I'm going to stop talking for a moment. I want you to try this one on your own. So I factored this. I could have done U substitution. You know, I'm the math teacher, so I can actually do it without the U substitution. After you factor it and put the cosine x back in, this is your factors. So then we're going to set each factor equal to 0. Oops. And then we're going to solve for each factor. I'm going to get cosine x equals -1, then divide by 2. Over here I'm going to get cosine x equals -1. So if cosine's negative, that's these two quadrants. Now the way that I know this answer is I know it's either a 30 or 60, I also know, because I'm memorized, that the sine of 30 degrees is a half. So that means this can't be 30 degrees, because the sine of 30 is a half. That means the cosine of what can equal a half? That's got to be a 60 degree. Okay? So then I just think in radians, I'm going to be counting by pi over 3s. But to get in this quadrant, we're going to have 2 pi over 3. And to get in the third quadrant, it's going to be 4 pi over 3. Then I go over here and I say, where is cosine negative 1? That's the kind that are right on the axes. To be negative, it's got to be on this side, so it's going to be at pi. And then the correct order would be 2 pi over 3, pi, and 4 pi over 3. A lot of you got that all the way by yourselves. So very good job. And then we get to this one. So rules of factoring. What's our first rule of factoring? Is there a GCF in every term? Ooh, how many terms do we have here? Terms are separated by plus or minus signs. So when I separate all these, we have 4 terms. So in all 4 terms, is there a GCF in all 4 terms? No. So we do not have a GCF. Katie, what are you dying to say? This is a factor by grouping kind. Yes. So we're going to group together the first 2 terms and the last 2 terms, and you're going to make sure you have a plus sign right in the middle. Then you get to factor each group individually, and our first step of factoring is GCF. So is there a GCF of the first group? Secant x. So that's going to come out front, secant x, and I'm going to have left over 4 cosine squared x minus 3. Plus, what comes out of the next? The number 2. Okay, so I'll pull that 2 out, and I'll have left over 4 cosine squared x minus 3. Now remember, from here, you now treat this like it's a binomial. It's separated by 1 plus sign, so now we're thinking binomials. So I look on either side, and my first step of factoring, is there a greatest common factor for either side? Is there a greatest common factor for this and this? 4 cosine squared minus 3 is the greatest common factor for these 2 terms. So I'm going to pull out 4 cosine squared x minus 3. I'm going to pull it out and put it in front. I have parentheses around it because it is 2 terms. But I am treating it like it's one thing. It's a group. And then from here, once I pull that out, these cancel, I have left over secant x plus 2 equals 0. So now we can solve each factor. 4 cosine squared x minus 3 equals 0, so cosine squared x equals positive 3/4 square root with a plus or minus. Cosine x equals plus minus radical 3 over 2, because I just square rooted the 3 and the 4. This one, secant x plus 2 equals 0, so secant x equals negative 2. I'll start with cosine x. Positive, negative, radical 3 over 2, that's going to tell me all 4 quadrants. What kind of triangle does it have to be if it's radical 3 over 2? It's 30, 60, 90. So either 30 or 60 degrees is what I'm thinking. I know that cosine of 30 equals a half. So cosine of what is going to be the radical 3 over 2? It's going to be 30. Plus we already did cosine of 60 was a half over on the other page. So this one's going to be 30, which is pi over 6. We'll have all the pi over 6's. And then secant. You know what? I don't have my secants memorized. I don't. But I know my cosine. So if I change this to cosine, x equals, what's it going to equal? It's going to be negative a half. I feel like we just did that on the other side. Did we not? What angles were those? So the pi over 3's. This will be 2 pi over 3 and 4 pi over 3. So now let's put them in order. X equals pi over 6. Then what? Which means 5 pi over 6 is next. 7 pi over 6, 4 pi over 3, 11 pi over 6, end of bracket. Let's check that one. Should we check it? This one might be fun to look at. If you're not interested in looking at it, then just work on the next one. But I'm always curious to see what they look like because they're always so crazy looking. Cosine squared x. I think I have to put that in parentheses. Secant x minus 3 secant x plus 8 cosine squared x minus 6. Look at this crazy thing! How fun does that look? It's a what kind of roller coaster? A nice roller coaster? I think it's a deathly roller coaster. Well, I don't know. This one's going to go infinitely far, and then this one's going to go infinitely far, and they're going to have like a little break. There's going to be an asymptote in there somewhere. But if we're looking from 0 to 2 pi, pi over 6, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, and 11 pi over 6. Okay? Last one. I'm going to call on people. Luciana, what should I do first? And? Cosecant. Oops, I just wrote cos. So we're going to subtract cosecant x, and we're going to add 2 at the same time to both sides. So we've got cosine, or cosecant cubed x minus 2 cosecant minus cosecant x plus 2 equals 0. So we need to say equals 0 in order to use factoring. Audrey. I'm going to factor by grouping. What do I have to have in the center? Audrey, do you know what I have to have in the center to do factor by grouping? Nope. Only one right answer. It has to be plus sign. So before I do factor by grouping, I'm going to change this minus sign into plus a negative. Okay? That way, the negative sign is going to go in the second group. The plus sign is in between the two groups. Dylan, Fall, what should I do next?
You should find the greatest common factor of both expressions.
Okay, so what is it for this one?
Cosecant squared.
Okay.
And for the second one, it would be -1.
Yes. Okay, so I'm going to rewrite this as cosecant squared x, parenthesis, what's left over, cosecant x minus 2. Then we're taking out a minus 1, so I've got cosecant x minus 2. This is where you look and you say, it is now a binomial. It's a binomial. I've got two terms. They look like crazy terms, but I got two terms. One is here, one is here. I'm going to treat this like a binomial. Your first rule of factoring is always GCF. Do we have a GCF between these terms? Is there something the same?
Yes.
What is it? Okay, so that is my GCF. Oh, I forgot a C up there. That's going to cancel out when we bring it to the front. After that cancels out, the other parenthesis will be what's left over. Cosecant squared x minus 1. You guys take a moment and solve each of those. Okay, so I solved each of these for cosecant x. Then I don't know cosecants, but I know sine. And I know where sine is a half. I feel like I've already said this twice to you today. Where is sine a half? 30 degrees. This is positive, so it's going to be in the first and second quadrant. It's going to be 30, which is pi over 6. So pi over 6 and 5 pi over 6. And then this again is sine. So I'm going to reciprocate this side, but reciprocating 1 is still 1 plus minus. So we're going to say where is sine 1? Well, sine is 1 at 0, 1, or it's negative 1 at 0, negative 1, right on that y-axis. So that would be at pi over 2 and at 3 pi over 2. They have to be in order, so we're looking around the circle. I come to pi over 6 first, then pi over 2, 5 pi over 6, and 3 pi over 2. Okay, and then you could use Desmos to check your answers, but I'm going to go ahead and leave that up to you. We will be doing a second section today, so you can work on this for a little bit, then we'll take a brain break and we'll start our next section. Okay?